Alright, gang, here we go. This is for Chem 1, Unit 7, Part 5. We're writing equations from sentences. This is kind of a cumulative little section here where pretty much we're taking all the skills you've learned in the last couple of units and putting them all together and seeing if we can figure out, based on if somebody wrote down the chemical reaction in a sentence form, if we could figure out what the chemical reaction is, and then vice versa. Alright, so we're just going to do several practice problems here, and hopefully it'll help you get some of the ideas of what kind of tricks and tools that you have at your disposal to help you figure out what's going on. Alright, so let's give it a shot. Here we go. So it says aqueous ammonium phosphate combines with aqueous silver nitrate to form solid silver phosphate and aqueous ammonium nitrate. Now that seems just like a bunch of gobbledygook, right? Okay, so really just start at the beginning and just start writing stuff down. Write what you know. Okay, so it says aqueous ammonium phosphate. All right, so ammonium phosphate. So ammonium is NH4. Okay, and phosphate is PO4. All right, but we have to think about the charges because this is an ionic compound. So ammonium has a charge of +1 and 1 plus, and phosphate has a charge of 3 minus. So that means we'll need 3 ammoniums to balance out that phosphate with that crisscross method, right? And then for states, it says that it's aqueous, right? So we're going to go ahead and write down that it's aqueous there as well. All right, so that's your first reactant. And then it says it combines with aqueous silver nitrate. All right, so our silver is Ag, and then nitrate is NO3. Think about your charges. Silver is +1 because of the 3-2-1 rule, and then nitrate is -1. Okay, and so it's 1 to 1, we're good to go. All right, and then it says with aqueous silver nitrate, so we'll put aqueous for that as well. All right. And then they went ahead and told us what the products were. But based on this, you can already tell that this is a double replacement reaction. So we wouldn't even necessarily need the last half of the sentence in order to figure out what's going on. But we'll go ahead and we'll do it based off what they say and see if it matches what we'd predict. All right, to form solid silver phosphate and aqueous ammonium nitrate. All right, so silver phosphate, so that's Ag, and then PO4 for our silver. All right, again, silver is +1, phosphate's -3, so we need 3 there. All right, and it says it's solid, so we'll go ahead and throw the S in there. That means it's a precipitate, right? Okay, and then aqueous ammonium nitrate. So NH4 for ammonium, and then NO3 for our nitrate, and that's aqueous. Each one is +1, and so there we're good. And we could balance this: 3 ammoniums, 3 ammoniums. All right, 1 phosphate, 1 phosphate. 1 silver, 3 silver, so we'll throw that 3 out there, and then 3 nitrate, 3 nitrate, we're good to go. All right, so there you go. That's our balanced chemical reaction. And you can tell that it would have been just fine. We would have been able to predict those products with our double replacement reaction knowledge. All right, let's do a couple more. All right. So metallic iron reacts with sulfuric acid to produce aqueous iron 3 sulfate and hydrogen. All right, so we got metallic iron, so that's iron, Fe, and it says it's metallic, which implies it's solid, okay, with sulfuric acid, so that's H2SO4. Now remember, our rules for naming acids, you ate something icky, okay, so that means it had to have come from the sulfate, which is SO4. SO4 has a 2- charge, so I put 2 hydrogens on there. And then it's with sulfuric acid. Acids will always be aqueous, okay? If you ever have a pure liquid acid, you're in big trouble. All right, so this is aqueous sulfuric acid. All right, and then it says produces iron 3 sulfate, so that's Fe, and then SO4 for our sulfate. Now iron, it says it's 3, so that means it's 3 plus, and then the sulfate is 2 minus. Okay, so we're going to have to crisscross a couple of things. So Fe2SO4 3, and it says it's aqueous, so we'll throw that AQ on there. All right, plus hydrogen. All right, so that's our H. Remember, hydrogen is diatomic, so we'll throw that H2 out there. We know based on the color it is on the periodic table that it is a gas. All right, and then we're going to balance it. So 1 iron, 2 iron, so I'll throw 2 out here like that. 2 hydrogens, 1 sulfate, 3 sulfate. Oh man, so I'm going to say a 3 there for that sulfate. And now we've got 6 hydrogens, so I need a 3 here for that hydrogen. All right, so there's our reaction. So this was a single replacement reaction. Okay. All right, now it says nitrogen gas reacts with oxygen to produce dinitrogen pentaoxide. All right, so we got nitrogen gas. Nitrogen's diatomic, so we'll throw that 2 out there. Gas plus oxygen gas. All right, oxygen is also diatomic. Remember your Brinkelhoff rules. All right, produces dinitrogen pentaoxide. All right, so that'd be N2 for the di, and then O5 for the pent. Right, and then it says this is gas as well. All right, so this is a combination reaction or synthesis reaction. We're going to balance this thing. All right, so two nitrogens, two oxygens, 5 oxygens. So we'll put a 2 here and a 5 here. Okay, and then that means we need a 2 for that nitrogen as well. Okay, not too bad, not too bad. Here we go. 2 more like this. Okay, we're just doing lots of practice. This is the only way to get good at these, is just to do practice. All right, so zinc metal reacts with aqueous copper sulfate. Oh man, so now they're not giving us the products. We're going to have to predict them. All right, so zinc solid reacts with aqueous copper sulfate, copper 2 sulfate. So that means it's got a charge of 2 plus, and sulfate, remember, from before is 2 minus. So that's going to be nice. So CuSO4. Okay, and it says it's aqueous. All right. All right, so that's going to form. So really, this is a single replacement reaction. So we need to look at our activity series. Okay, and so we got to find our activity series from way back here. We've got zinc and copper. Zinc is more reactive than copper, right? Zinc's right here, copper's right here. So our reaction will occur. All right. There we go. So our reaction does happen. So we go zinc, and remember our 3-2-1 rule. Zinc always makes a 2 plus charge. Okay, so it'll get 1 sulfate. Okay, and then adding in copper, and copper by itself would be a solid. But what would the state on this be? Well, we have to look at our polyatomic ion sheet to see if it's soluble or not a polyatomic, our solubility rules. So sulfate. Okay, see how everything kind of comes together. Sulfate is always soluble. See, it's right here. It's always soluble unless it's with strontium, barium, mercury, or lead. Okay. Zinc is none of those things, so therefore that would have to be aqueous. Okay. Didn't really leave myself a lot of room there. But anyway, and then we could balance it, but we have 1 of everything, so we're good. All right, so that was a good example because it kind of went back and we had to look at our activity series, and we had to look at our solubility charts. All right, pretty fun. All right, ethane gas burns in the presence of oxygen. So you should recognize right away that this is a hydrocarbon. So that should tell you, and it's burning in the presence of oxygen. All right, so C2H6, and it says it's a gas. That's nice. Burns in the presence of oxygen. So that's our O2 gas. You should see right away this is a combustion reaction. So we always make CO2 gas and H2O. And we know H2O is a liquid at room temperature. All right, so C2H6, so 2 carbons. All right, 6 hydrogens, 3. All right, and then how many oxygens do we have? We have 2 oxygens here, or 4 oxygens, excuse me, plus 3, so that's 7. Remember our trick, we're going to make that guy 7 halves. All right, and then in order to get rid of that halves, because we can't have half of an oxygen molecule, we're going to multiply everything by 2. So I'm going to erase all of these guys. See if I can remember what they all were. So we're going to throw a 2 on this guy, which means this guy was 7. All right, so it meant this guy was 4 and this guy was 6. Double check, make sure it's all balancing out. So we've got 4 carbons, 12 hydrogens, 14 oxygens. Let's see, 4 times 2 is 8 plus 6, so that's 14. So we're good. All right. Last little example here, we're going to do one where we go backwards. So instead of having what's written, or trying to figure out what the equation is, and then write out, and then right now we're going to give you the equation, and you're going to try to figure out, well, how would I explain this to somebody in words? All right, so you're just going to start saying, you're going to say solid zinc, and I'm not going to write it out, reacts with, and then you're like, all right, what's the name of this guy? Well, it's an acid because it starts with an H, so this would be hydrochloric acid. And you could say it's aqueous hydrochloric acid, but that's a little bit of a, you're just really saying the same thing twice because all acids are aqueous. All right, so solid zinc reacts with hydrochloric acid to form aqueous zinc chloride and hydrogen gas. So it's essentially the same thing. We're just moving left to right, right? Here's our solid zinc, reacts with hydrochloric acid, right? And I know it's with because they're added, right? To form, and that's what this guy here tells us, aqueous zinc chloride. So aqueous zinc chloride and hydrogen gas, right? And hydrogen gas. So that's it for part 5. I know this is probably one of the trickiest things that you have to do, but it's a really, really important skill moving forward, especially as we move forward into stoichiometry next unit. All right, so do lots and lots of the practice problems I've provided for you, okay, and do as much as you can. Check your work, make sure you're doing them right. All right, and let me know if you have any questions, and I'll see you on the flip side.